Greetings students and welcome to our Calculus 1 class. Today we are going to be solving a very important problem from Calculus 1. And the question says, for what values of r does the function y equals e raised to the power of rx satisfy the equation y prime prime plus 6y prime plus 8y equal to 0. So to solve this problem, we have this function and we are asked for what value of r does this function satisfy this equation. What we need to do is to find the derivative of this function based on the highest derivative in here. So first derivative, second derivative, and then we'll substitute all of those values in this equation and then see if we can solve for the values of r. So let's do that. So for the solution, we have y is equals to e raised to the power of rx. Let's find y prime. So the first derivative is y prime is equals to, if we differentiate e raised to the power of rx, the rule says we should differentiate rx with respect to x. The derivative of rx is just r. Multiply that by e raised to the power of rx. That's the first derivative. For the second derivative, we differentiate this side. So r is a constant. If we differentiate e raised to the power of rx, we have the same r e raised to the power of rx. But then if we simplify, r times r is r squared e raised to the power of rx. So the second derivative of that function is r squared e raised to the power of rx. So what do we do once we've done that? We can take this equation and then substitute these values or these derivatives into that equation and then simplify. So we know the equation we are given is y prime prime plus 6y prime plus 8y equal to 0. This is the equation. So what is y prime prime from this equation? So from the derivative from here, what is y prime prime? That's r squared e raised to the power of rx plus 6. What is y prime? Y prime is r e raised to the power of rx plus 8y. What is y? Y is e raised to the power of rx. And the entire expression should give us 0. Once we do that, we will realize something very important. We realize that we have e raised to the power of rx on each term, right? Being multiplied by each term of the equation. So we factor out e raised to the power of rx. So we factor this out, we have r squared plus 6r plus 8 equal to 0. And since e raised to the power of rx is never 0 for any value of x, we can divide each term by e raised to the power of rx. So we just have e raised to the power of rx. So we have r squared plus 6r plus 8 equal to 0. We can divide this term by e raised to the power of rx because it's never 0. Divide this term by e raised to the power of rx. So if this cancel out, we are going to have r squared plus 6r plus 8 equal to 0. And based on this, we can factorize this equation. So this is a quadratic equation. The factor will be r plus 4 and r plus 2 equal to 0. And if we use the zero product property, we have r plus 4 equals 0, r plus 2 equals 0. We send this across, r is equal to negative 4 and r is equal to negative 2. So we have two values of r for which this function satisfies this equation. Therefore, r is equals to, we are going to use a set notation, negative 4 comma negative 2 equals this. And that is the result. Thank you very much for watching this video, and we hope you subscribe to our YouTube channel and click the notification bell so that you won't miss future updates of our videos. Thank you very much, and God bless you.